Iceland is a land of extremes, where fire and ice coexist in a dramatic and often unpredictable dance. Volcanoes erupt, glaciers slowly creep across the landscape, and tectonic plates continuously reshape the island from deep beneath the Earth's surface. For decades, scientists believed they had a solid understanding of this rugged land. They tracked eruptions, mapped fault lines, and studied ancient lava flows with painstaking detail. Yet a recent discovery beneath the surface has challenged everything experts thought they knew, revealing hidden layers of complexity in both Iceland's geology and human history. At the heart of Iceland's extremes is its position on the mid-Atlantic ridge, where the North American and Eurasian tectonic plates slowly pull apart at a rate of roughly 1.5 inches per year. This gradual separation allows heat and molten rock from deep within the Earth to rise, fueling the island's volcanic activity. Iceland has over 100 volcanoes, around 30 of which are still active. While some are clearly visible, others lie hidden beneath glaciers. When these ice-covered volcanoes erupt, the heat can melt massive amounts of ice almost instantly, triggering sudden floods that race down valleys with little warning. The 2010 eruption of geological illustrated this perfectly, sending ash clouds across Europe that grounded flights and disrupted millions of lives. A single Icelandic volcano, it turns out, can influence life far beyond the island itself. Heat beneath the surface also sustains life above ground. Geothermal energy warms homes, fills hot springs, and powers Iceland's famous spas. Life may look calm on the surface, but below, the island is constantly active, under pressure and in motion. It was in this hidden subterranean world that researchers recently stumbled upon a discovery that amazed both archaeologists and geologists: an intricate network of human-carved caves, long hidden beneath the volcanic rock. This discovery came in the south of Iceland, near the historic area of Reykjavík, during the routine archaeological survey. Initially, the site appeared ordinary, but careful testing of the soil revealed unusual hollowness and soft spots beneath the surface. When researchers removed the top layer of soil, they uncovered a small opening leading underground. At first glance, it could have been a natural lava tube, but closer inspection revealed unmistakable signs of human craftsmanship: smooth walls, tool marks, and carefully shaped spaces. As excavation continued, the opening revealed a far more elaborate system than expected. The researchers discovered interconnected chambers linked by narrow passageways. Some rooms were wide with flat floors, while others were tight and enclosed. The layout suggested deliberate design rather than a simple pit or temporary shelter. Such stone-cut spaces are rare in Iceland because early settlers typically built homes from turf and wood, which decay rapidly in the country's wet, windy climate. Stone chambers, in contrast, endure for centuries, preserving a tangible record of human life. Historians and archaeologists quickly connected the caves to Iceland's early settlers. Most experts believe the chambers date to the Viking Age, roughly 800 to 1060 AD, when Norse settlers arrived from Norway and neighboring regions. Life in early Iceland was harsh. Trees were scarce, wood was precious, and the climate was unforgiving. Digging into volcanic rock offered protection from strong winds, heavy snow, and freezing temperatures. Underground spaces also maintained more stable temperatures than the surface. Radiocarbon dating of charcoal and organic material confirmed the Viking-era origin of the caves, reinforcing evidence from tool marks and room layouts that pointed to human ingenuity in planning. These caves, however, present risks even today. Volcanic rock, though seemingly solid, weakens over centuries. Rainwater and melted snow seep into cracks, freezing and thawing repeatedly, which gradually widens, fractures, and weakens the structure. Loose rock can fall unexpectedly, and even a small piece can be fatal in a confined underground space. To ensure safety, researchers use ground-penetrating radar and other scanning technology to detect hidden weak points. Subtle ground shifts caused by the thousands of small earthquakes Iceland experiences each year add another challenge. Air quality can also be dangerous, as oxygen levels drop and carbon dioxide can accumulate in sealed spaces. While archaeologists focus on human history, Geologists have uncovered findings that challenge previous assumptions about Iceland's formation. Analysis of seismic activity, gravity measurements, and heat flow revealed that the crust beneath Iceland is unusually thick. Most mid-ocean ridges have oceanic crust about 7 kilometers thick, but in Iceland it can exceed 30 kilometers, comparable to continental land rather than oceanic crust. This discovery has led to the hypothesis of Icelandia, remnants of ancient continental land buried beneath the island. The theory suggests that when the Atlantic Ocean opened millions of years ago, parts of an older landmass did not fully sink, and Iceland later formed atop this thick, partially continental foundation. This could explain the island's unusually vigorous volcanism and unique geological characteristics. The discovery of these Viking Age caves, combined with evidence of Iceland's thickened crust, highlights how humans adapted ingeniously to an extreme environment while also revealing a more complex geological story. The same volcanic rock that preserved shelters for early settlers is part of a deeper history that stretches back millions of years. Iceland is not just a land of volcanoes and glaciers. It is a living archive of both natural and human history, preserving traces of life and geological processes over centuries and even millennia. Exploring these caves requires careful planning, meticulous preparation, and advanced technology. Each chamber provides a dialogue with the past, walls that tell of survival, ingenuity, and adaptation, while surrounding geology tells a story of tectonic shifts, volcanic eruptions, and glacial movements. Iceland serves as a natural laboratory where the forces of nature and human resilience intersect. Every excavation, radiocarbon test, and structural analysis adds to our understanding of the island, revealing it as a place where history is not only written above ground but also etched into stone. Ultimately, the findings beneath Iceland remind us that no place is ever fully understood. Viking Age caves carved into volcanic rock and the presence of unusually thick crust show that Iceland's landscapes are far more intricate than they appear. It is a place where natural forces and human ingenuity intertwine, preserving records that challenge our assumptions about the past. Beneath glaciers, volcanoes, and lava fields lie secrets that continue to reshape our understanding of human survival and the dynamic Earth. Iceland's hidden history is a reminder that the Earth can still surprise us, and that the story of this remarkable island is far from complete.